Shout out to the incredible listeners and supporters of this show who are donating to it on Patreon. Getting the equipment, getting the software, planning things out, this whole deal is only possible because of you. Thanks. Welcome to a special installment of the K-12 Engineering Education Podcast, Season 3. I'm Pius Wong, your host and interdisciplinary engineer in the education industry. Today I'm joined by Sadhan Sathyaseelan, another engineer and education researcher. And in today's episode, we're piloting a new podcast series that helps you straight up learn hard engineering. Join us on this experiment next. Welcome, Sadhan.
Hi, Pius.
So, Sadhan, you came to me several days ago,
Okay.
and you're like, hey, Pius, I have an idea for a new show series for the podcast. And I was like, what is it? And you told me, well, you just started your PhD recently, right?
Yes.
And you're getting ideas about education and teaching more people about engineering.
Yep.
And then I understand that you want to give like the experience of going to engineering school to anyone who wants it through this podcast. Is that right?
Yes, but not exactly the engineering part.
That's a very polite way to say I'm wrong.
Yes, it's a very polite way to say it.
So what is it?
Okay, so I'm thinking more like, hey, how about we give people engineering concepts without the math?
Without the math.
As concepts, yes.
And why?
We both agree on the idea that essentially what we're doing with our K-12 Engineering Education podcast, this production, is we want to educate people on basically what's happening in science and engineering. That's what we're doing. Technology and all of that. So I thought like maybe we can also go a little bit further and teach people the terminologies that's involved in engineering that people speak often. And if you look at with everything that's happening in the world with Musk sending people to Mars.
Okay, I thought you were going to go another direction.
Okay, yeah. Essentially, you see the newspapers full of climate change.
Yes,
that's what you thought. Okay,
I thought you were going to be like, okay, there's the business side and the technology side, and then there's this political side of people ignoring
exactly
science and knowledge and data.
Yeah. I've had difficulties with before I was an engineer to even understand like what this means. Even after engineering, I still did not really get some of the core concepts. It takes some time. So I thought like, why can't we have a conversation like we usually do, and we don't get too technical, and we don't talk about any math, but we do talk about the fundamental concepts of these engineering ideas. And I think that might equip people who are listening on just the terminologies and those concepts. So if they come across it anywhere else, they'll know what they're talking about.
They'll actually know instead of just ignoring it, tuning out, or assuming.
Yeah. So
that's a good goal.
Yeah. I think if we make it into a really, really, basic level, conceptual level, it should be great.
So we're talking not just one episode, not just this one little segment that we're doing right now. You're saying several episodes to talk about different concepts? Yeah.
So I'm thinking, I think we should pick a certain engineering field, mechanical engineering.
Hey,
and
that makes sense.
Talk about all of what mechanical engineering is. Doesn't matter how much time it takes.
Sure. Yeah, that sounds good because you are a mechanical engineer.
Yes.
I was/am a mechanical engineer, so maybe that's a good way to start out.
So we both have a lot of experience on that.
I've already mentioned before, if people have
I think you should do it again because this is a new concept.
So, no, I actually started out as a biomedical engineer, a bioengineer officially, in fact, which is a little different from biomedical engineer. My first full-time job was helping research prosthetics, knee replacements, actually. The stuff that goes into your body when you get older, usually, and your knee starts to give out because the arthritis is taking over, and you have to have surgeons cut out the bad parts and replace it with metal and bioactive materials and all that stuff. So as a biomedical engineer, I used a lot of mechanical engineering. And then I decided to learn more about mechanical engineering and went to the University of Texas right here in Austin, studied robotics and biomechanics and all that stuff, and got my mechanical engineering degree.
Masters in mechanical.
Masters in mechanical. Yeah.
And you also have experience working in the field and teaching engineering.
Yeah, so it's funny, like after coming to UT, when you go to grad school, they make you teach. And I always tell people, well, I never thought I was going to be a teacher, but I really liked it. I tried avoiding it forever, and UT made me teach, and I liked it. So they sucked me in, and I started teaching mechanical engineering stuff.
Awesome. And I think you should also mention about you teaching teachers.
That's true. Yeah.
That's what the other podcast is about.
That's where we met. Yeah.
So it's a...
We worked at engineer. No, I forget. It's already been so long.
Engineer Your World.
Yeah, there is this high school curriculum called Engineer Your World.
Yeah.
They aren't paying us right now to advertise it, but they teach high school kids how to do, the fundamentals of engineering design specifically. And I think for mechanical engineers, especially what I learned in grad school here in Texas in mechanical engineering, I learned that design is so critical, and I learned so much. Like, props to UT grad school. Like, I learned so much.
I agree. Yeah. I agree totally.
Yeah, and I could name drop the different professors who I appreciated, but people can look it up. Yeah. But I think that the stuff that I learned in grad school, we because you also worked for them, Engineer Your World, we transferred that to the curriculum in Engineer Your World, and then we taught these high school teachers how to teach engineering design to other students. It's all very meta. Teaching teachers how to teach engineering.
Multi-level inception.
So talk about your experience in engineering.
Okay, so very similar to yours, right? So I'm a mechanical engineer. I have a master's degree, and I worked for Engineer World in developing high school curriculum in engineering. And
you did more than that too. You helped teach engineering students about calculus and other stuff?
Yes, that was a different project, but yes. So both K-12 and also
you
freshman
did
level
all the
engineering.
Ages. Yes.
Yeah, I guess so. Yeah.
You did from like young kids K through 12 through undergrad through masters then because of the teachers and the grad students.
Oh, I never thought about it.
You did teachers who are about to retire. You did all the ages.
Interesting. Okay. I did teach them, but I also learned a lot from them. So I guess it's more of I don't really look at it as I taught these people. No, I guess it's core learning kind of a.
That's
idea.
very nice of you to say.
I think that's what it is.
No, that's actually how I think it should be. I mean, the best teachers that I've always known have always, it sounds sappy, but they've always said, I learned so much from teaching you students. But it's true. Yeah, it's true.
Yeah. It's like, I know the perception, but that's what it is. So my motivation for doing this is, like we discussed, is I do want to equip somebody who's not in engineering, somebody who hasn't done a lot of science, on the terminologies we talk about in engineering, and that's my motive. And it's just an attempt to equip people who might not understand these concepts, or it might take a long time to get through these concepts. If you can give them like a very, very, very direct, conceptualized idea of these concepts, I think that'll be a great, equipping them with those terminologies and ideas will be a great thing. Yeah. Because these are not like engineering. It's like a highly, unique thing. People, you need to spend years to understand. It's none of that. It's just it's the understanding of natural world. So that's what my motivation. So I would love to hear yours. Like, what's your motivation?
It's very similar. I mean, in doing the podcast now for almost by the time this episode's up, it's probably been 2 years. I think that it's pretty clear that everyone thinks there should be more awareness and understanding of engineering concepts. And not just if you're going to be an engineer. Just like you. Like, I think that I believe that the common person, that sounds so bad, but like the average person, you should know about the internet. You should know about how cars work. You should know about climate change, to use that example again. You should know about medical technology. Like, there's so many things that I think people should have, that conceptual, fundamental, more that basic knowledge that sometimes isn't there. I think some people are afraid of technology, or are afraid of engineering, or they're afraid to say anything about it for maybe sounding stupid. So it's like, hey, I don't know so many things in engineering or otherwise. Yeah. So it's like, if I can say, I don't understand this on this podcast, maybe that'll help motivate other people to ask questions as well.
No, I think you brought a very good point. So you are a biomedical engineer and I'm a mechanical engineer.
I will say that my biomedical engineering knowledge has...
same thing. My PhD is not exactly in mechanical engineering.
Engineers change.
But essentially what I've, as a discipline, I've learned through only what's in the realm of mechanical engineering. So you only learned what's in the realm of biomedical. So I guess as we do our podcast, we'll have to learn a lot.
Oh, totally.
So it makes sense. It's just we learn and we try to communicate that.
Yeah. One of the best pieces of advice I think that I got from a working engineer friend of mine from back in Tennessee, he told me that, like, in his opinion, a good engineer is a good engineer. In other words, he meant like, it doesn't really matter if you're a bioengineer or a mechanical engineer or an aerospace engineer. Like, yeah, there's all these different fields, and yes, engineering is so wide and so broad, but there comes a point, at least for him, where he was looking to hire people not because they studied, biomedical engineering in orthopedics, like I did or something, but because they've proven that they can problem solve, that they can learn stuff that they don't know, and do it responsibly, efficiently, whatever. That's what he was looking for. And that transcends a discipline.
I think it's a very valid point. And I would also add a good grasp of basic concepts in engineering.
Yeah, exactly. No, you're right. Being able to talk about things that they do know and that they don't know. Yeah. There are some threads that are common amongst all these engineering disciplines, whether you're studying software or robotics or whatever, chemical engineering. And I think that's kind of what he meant. Like, have those fundamentals. I think math is one of those fundamentals.
Yes, which we're not going to talk about.
No. But like, the whole point of this podcast is to make it interesting to talk about engineering. I don't want to sit, like, I'm an engineer and I don't want to sit in front of a lecture hall listening to someone drone on about how to do, like, a Fourier transform again for, like, the third time in my life. Like, I'll just look it up on Wikipedia or whatever.
Right.
But, like, what I do want is to talk about it, how it looks cool when you visualize Fourier transforms, how it's great for creating music and like, there's all these other interesting aspects related to engineering that I think you can have a great conversation about without getting too stuck into the weeds. And I hope that's what we do.
Yeah, I think that's exactly I think we're on the same page on what we want to do.
Awesome.
I was going to start off with asking the fundamental question. Engineering. I think that's the fundamental question I have.
What is engineering?
What is engineering? Like, we are engineers. So what is the fundamental definition or idea of what engineering is? What do you think that is?
I'm resisting the temptation to look it up on Wikipedia right now.
Oh, we're not looking up anything.
Yeah, no. So I'm actually reminded immediately of the very first episode that we recorded with you, me, and Rachel.
Okay.
Actually. And I remember that in that pilot episode of this podcast, we asked something like that.
Similar. Okay.
Yeah, and I remember that we had a discussion of, like, what's the difference between science and engineering and technology and all that stuff. And one of the points was engineering might ask the question, what if? I think that was what someone had said.
I remember that, yes.
You do remember? So beyond that, I'm thinking, basically, I think engineering is the creation of new stuff. Maybe if I wanted to say what they taught me in grad school, I would say, and what we used to teach to our high school teachers, I would say engineering is the discipline where you learn how to study and create technology to meet the needs of people and customers and users.
Okay. So what's the technology?
Yeah. And maybe that's the stuff we create. I don't think it's, for me, actually, I don't think it's just stuff that humans create, but I think that it includes stuff that humans create.
Okay.
What do you think?
So there is a creativity part involved, but I think essentially what we're trying to do is we take what's existing in terms of raw materials and we manipulate it based on our understanding of science. We manipulate it in a useful way that'll solve a certain activity that we want to perform in a more efficient way.
To create a solution to a problem, maybe to perform a goal, like perform something according to a desire, goal, something like that. I think that sounds accurate. It makes, when you said raw materials, it made me think like, tons of this engineered stuff is physical stuff. And maybe some of the stuff isn't too. Like, it's stuff you can't physically touch, but it's still engineered.
Right, yeah.
So I wonder how you would define that.
Maybe the data? That could be just raw data.
For example, or you could engineer a computer simulation or a mathematical model or something in Excel. I'm doing a lot of computer programming lately, so that's why that's on my brain. And then it makes me think, okay, is cooking engineering? Is painting engineering? I don't think so, in my opinion. Maybe there's aspects of it related to engineering. So what's the difference? Or do you even agree with me?
I think there's a certain level of engineering involved in cooking art. I'm not entirely sure.
There's overlap. I think in the Venn diagram of this.
There's definitely an overlap on just the state of mind. We're not talking about what engineering as a book definition.
Yeah.
As a state of mind, I think
engineering is a state of mind.
It is a state of mind, right?
No, it's the phrase engineering thinking that teachers use officially in the state of Texas. Engineering thinking is written into the educational standards, so I think that's what you mean. Engineering thinking versus engineering.
When your friend in Tennessee said a good engineer is a good engineer, he's not talking about what the person knows. He's talking about a certain way of approaching things.
Yeah, no, you're right. I didn't think about it that way. But he's probably thinking about your mindset, your way of solving problems.
So is engineering, is that a noun or a verb? How is it? How do you look at it?
Officially, it's both. So I am an expert, of course, because I'm actually not. But no, I have another podcast called Engineering Word of the Day, and engineering was never one of my words, but I should do that.
You should definitely.
But this is probably a podcast episode for that podcast. But it's definitely both a noun and a verb. I mean, according to the English language, engineering, it's like the present tense progressive form of engineering.
Interesting. Okay.
It's all engineer is a person who is an engineer, and then engineering is someone or is the act of. It's
an action that's happening.
Problem solving and creation of solutions, that kind of thing.
So I wonder when engineering started, because right now it seems like when you talk about engineering, it seems like it's a phenomenon in the modern world, in modern science, because based on a lot of modern science, you have all these universities teaching engineering, which seems like a very current thing or a modern thing. But is it so? Because if you look at simple civil engineering, pyramids, that's a certain level of engineering that was happening there.
Oh, there totally is. I agree, and I think that experts would say that civil engineering was probably the oldest form of engineering. Basically, when the construction or creation of tools grew to such a scale where it required systematic thinking and meeting a bunch of customers' needs. I think the definition of engineering is fuzzy, but I do think like once people started to have to build roadways or houses on a bigger scale, or
I think you brought up two important points that I love and I can relate to a lot. One is a systematic thinking. And the other is customers.
So what does that mean? What is systematic thinking? I know I said it, but now I have to think about what does systematic thinking mean?
To me, it seems like, I'm going to think in terms of early man. Okay, engineering, as we were looking at it as a state of mind, engineering was there for a long time when humanity started using tools, right? So they did engineer tools. And the way I'm thinking at that, what's the engineering there is, there are so many ways they can approach this problem, but over time they had learned to do it a certain way
to make the
best
optimal, faster, better, optimum.
Yeah,
there we go. Okay.
In terms of how the spear turns out to be.
They aren't just randomly making spears.
They're not randomly doing it,
because that we would say is not. I would say that's not engineering. No. Randomly making stuff and just guessing which spearhead is the best one. Maybe that's not engineering.
Yeah, they trial and learn. They were using trial and learn, but there was a systematic way of doing it.
Okay.
Experimentations. maybe over generations, not one person doing it.
Sure.
But there was an engineering and humanity, they kind of go together.
There's probably some engineering thinking, some strategies that carry over to today.
Definitely had to.
Yeah.
And the other thing is customers. It's who are you building?
That is so business sounding too. Like when
it's
I
business sounding,
yeah.
But we did talk about it needs to be useful. That's the difference between engineering and science.
And an artist or there's an actual application.
Utility. What's the utility? And if you're talking about utility, who's going to use this? And that's the customers, right? Even though it's a business lingo, it's also very much engineering lingo.
Could the customer be oneself? Like, can I engineer something just for me to use?
I think so.
Or does it have to be for other people? Like when we say customers, we mean any person.
Anybody.
Yeah. Can maybe it be
users? Maybe that's a better
I've heard that actually. No, I've heard that too. I've heard both, and
yeah,
they're not even exactly the same thing too. Because like we talk about engineering products for kids, for example, the kids use I don't know, the Nintendo Wii or something, but the parents are paying for it.
They're the
customer.
Oh, okay,
like so I don't know. There's fuzziness around these definitions, isn't there?
Okay, but I think in terms of engineering itself, we are more leaning towards we are interested in the users.
Okay.
Who's actually going to use this, and that's what we are designing it for, right? Yeah. Customers is definitely on the business world side when the money is involved. All right, that's a pretty good definition.
I mean, they engineer stuff for animals too, like I don't know, engineering a dog toy or something. I guess the human might be using that as well. But like there are things that you engineer for an animal too. And it's like, so maybe it's not even just humans. I don't know. Or plants or something.
I guess end users or users. What's this used for? What is it used?
Once we go into the future and we meet other aliens and everything, then we'll go on to any sentient or non-sentient being can be our customer. So I'm just waiting for the future.
Oh, me too.
Yeah. And as people have learned, if they've listened to the podcast, one of your favorite movies is Interstellar.
Oh,
There's a lot of engineering in there.
I'd probably bring this up a lot during the...
We'll relate every single discipline to Interstellar somehow.
Probably, yeah. No, maybe. But we will talk about movies. Movies are a great, way to explain concepts that... that might otherwise be hard to visualize or communicate just through verbal podcast.
Right. Like when people learn, and teachers already know this, but they've taught me this. There's many ways of learning, and one of the ways to learn, one of the ways to create designs too, is learning through analogies. And so movies, I think, oftentimes let you visualize things that you might not be able to visualize otherwise. They give you analogies to think about.
Video games,
yeah.
I think pop culture.
Right. You get to think about things in a more interesting way. If you're more engaged, maybe you'll remember it more. So I hope that we
should definitely
make listeners.
No, that's a great idea. I mean, I'm sure we would have done that anyway, but we're just putting it out there, meta. We will be talking about pop culture in terms of engineering as a drawing example.
Right.
We have to. I don't see how we can explain certain things. With examples.
Right.
All right, that's awesome. So, are you comfortable with whatever we discussed about engineering for what it is in its core?
Yeah, we said a lot.
Okay.
I'm comfortable with it. Let's distill it down.
Okay.
So if no one got anything from what they just listened to, what is like the one thing they should come away with about what is engineering?
Okay. From my perspective, I think one thing that everybody should understand is engineering is not a modern phenomenon. It's something that humans have been doing for millennia. It would reframe the idea of, this is something new that I should learn from scratch. No, this is something that's already been happening with humanity. In terms of looking at what engineering is, I think that's a getaway from my perspective. How about yours? What would you say?
I would only add the part that I always gravitate towards anyway, that engineering is design and creation of cool stuff to solve a problem or meet a need. I think that's what it is to me.
Okay, awesome.
Yeah. What do we have to look forward to for future episodes?
So I think that'll be awesome to start with mechanical engineering.
Awesome. So people listening are going to get a mini mechanical engineering degree.
Crash course. Yes.
They could go up and talk to any engineer about mechanical stuff.
So how detailed are we going to get into this? So
I don't know.
We've established it's going to be mechanical engineering. We're going to talk about mechanical engineering.
Yeah.
I'm kind of anticipating at least 10 episodes in order to talk about all the different branches or all the different topics.
In mechanical engineering.
Yeah, in a bird's eye view. Not so much so in detail, but in a bird's eye view, what is mechanical? What exactly happens in there?
Yeah.
And what are the different concepts? And what are the different concepts that they learn under those concepts and under those concepts?
It's like if you were designing a school, these are the main concepts that you think, these are the classes that people should take.
Yes.
In a
So
way.
like
But not a class. This is not a class. These
not.
are these are the coolest conversations that you can have when talking about mechanical engineering and understanding it.
Yeah, because
Yeah.
math is not involved.
Hey, I love math, man.
I'm not saying I don't love, but it's not exactly accessible if you talk about math and
Maybe.
average person.
Maybe.
Okay. All right.
Till
So
next time, right?
I think so. So we'll
All right.
we'll come back and we'll talk about mechanical engineering.
Thanks, Sylvan.
Awesome. Thanks, Pius.
Thank you, listeners. For transcripts, links, and other notes related to today's episode, visit the podcast website, k12engineering.net. That's K12 engineering.net. There, you can also subscribe to the newsletter, get links to the Facebook page, Twitter profile, and much more. Remember to subscribe to the podcast itself on iTunes, SoundCloud, Stitcher, Player FM, Google Play, or wherever you find your podcasts. And finally, I cannot do this without your generous support of the show on Patreon. If you like this podcast or any of the other podcasts or projects from my studio, Pios Labs, please donate at patreon.com/Pios Labs. That's patreon.com/PIOSLABS. Today, our opening music is called Soar, and our closing music is called Polar, both by the artist Chris Pop. You can find more music by Chris Pop on SoundCloud under the username ChrisPop99. That's Chris with a CH. Or just check the show notes for a link. The K12 Engineering Education Podcast is a production of my independent studio, Pios Labs. As always, thanks for listening.